Greeting of the day and welcome to this video. In this video lecture, we'll be dealing with Vant Hoff factor. Vant Hoff factor basically was used up for determining the molecular mass, and here on the basis of Vant Hoff factor, students, we analyze that where the association or where the dissociation of molecules are taking place. I is considered to be the Vant Hoff factor. So how that is used up, that detail will be studied into this video lecture. So get ready for it.
So students, the association and dissociation we have got in the abnormal molecular mass. We know that abnormal molecular masses were obtained because when we use the colligative properties, in colligative properties, the four colligative property, that is elevation in boiling point, depression in freezing point, relative lowering of vapor pressure and osmotic pressure, when they were employed in calculating the molecular mass of unknown solutes, it was seen that because of the association the molecular mass have doubled or tripled, and because of the dissociation the molecules, they have been dissociated if they were ionic compounds, and the mass of one ion was only considered there, so the value has decreased. So that was clearly observed by Vant Hoff, a scientist, and he gave the Vant Hoff factor. And the Vant Hoff factor says that or rather we can say is defined as the ratio of normal molecular mass to the abnormal molecular mass, means the one which is expected and the one which we have got, or rather we can say the ratio of observed colligative property to the normal or calculated colligative property. I is equal to, I is the Vant Hoff factor, students, which is equal to normal molecular mass upon abnormal molecular mass from the first relation, or observed colligative property upon normal colligative property. If this is a condition which you should remember, if the value of I is equal to 1, then it's the normal mass, means neither the association nor the dissociation has taken place. But if the value of I is greater than 1, then the dissociation has taken place, and if the value of I is less than 1, then association has taken place. And this gives a criteria with the Vant Hoff factor that just by knowing the two masses, that is normal and abnormal molecular mass, we are in position to state the dissociation or association of the molecules. Now we calculate, when we say the molecules have associated or the molecules have dissociated, so how they are dissociated and what is the extent. Degree of association is what, students? Degree of association is nothing but the amount of association which has taken place. If we consider the association, then how much of the association? This is a simple parameter. If I am taking both of my palms, then 1/4 of my palm has overlapped 1/4 of my second palm, so I'll say the extent of overlapping is just 1/4 of my palm. But totally if I have covered, then is the total covering of the two, that is known as the degree of covering. Similarly, it's defined as the fraction of total number of moles of the solute which associates in solution at equilibrium. So alpha, that is the degree of association, is given as capital M, which is number of moles associated, upon into I minus 1 upon 1 minus M. Again I repeat, alpha is equal to capital M into I minus 1 upon 1 minus M, where M is the number of moles associated. Similarly, when we calculate degree of dissociation is defined as the fraction of total number of moles of electrolyte which dissociates into ion in solution at equilibrium. So alpha is equal to I minus 1 upon M minus 1, where M is the number of moles of dissociation. Again, one thing is very clear, students, that's why I specified, taken both of them onto one slide so that you are not confused. In the first case, we are taking capital M as the number of moles associated, while the same capital M in the case of degree of dissociation is considered to be the number of moles dissociated. So that is one and the same, because either it may have a dissociation or it may have association, so you should not be confused with it. So this is the value of M. Now taking a numerical over it so that it becomes easier, because this was a concept which was having a slight variation. The numerical says 19.5 grams of CH2FCOH is dissolved in 500 grams of water. The depression and freezing point of water observed is 1 degree Celsius. Calculate the Vant Hoff factor and dissociation constant for fluoroacetic acid, that is CH2FCOH. Now, for that, molarity we know is equal to W2 into 1000 upon M2 into W1, that is 19.5 upon 78 into 1000 upon 500. So when we calculate it, it comes as 1 by 2, 1000 upon 500. So del T is equal to 1.86 into half, that is equal to 0.93 K, and I, that is delta T observed upon delta T experimented, is equal to 1 upon 0.93. So alpha is equal to 0.0753. I is equal to 1 into alpha, that is 1 plus 0.0753, that is equal to 1.0753. And when we substitute this value into Ka is equal to C alpha square upon 1 minus alpha, so 0.5 square, that is alpha, into 0.075 whole square upon 1 minus 0.075, that becomes equal to 3.04 into 10 to the power minus 3, which is the expected answer. So that, with the help of numerical, I have explained over here. So let me recapitulate the total process of association and dissociation and the Vant Hoff factor. So to recapitulate or revise, in this 12th topic of the chapter solution, we have considered Vant Hoff factor. Vant Hoff was a scientist who worked on the parameter of association and dissociation, which was a concept in the abnormal molecular masses, or rather more specific, the 4 colligative properties: relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, and osmotic pressure. They were totally employed in calculation of, or the determination of, molecular mass of unknown solute which were obtained from the Earth's surface. So when it was observed by the scientists that there are either the association or dissociation, Vant Hoff worked over it, and on the basis of the observed value and the calculated value, he gave a relation which was known as Vant Hoff factor, which was depicted by I. So with the help of I, there were the conditions of association and dissociation which were made clear by Vant Hoff, and we had taken a numerical, only a numerical over here, because we'll be coming up with more of the numericals and questionnaire session. So thanks a lot for listening to this concept properly, and studying with this video will give you more of the concepts, because you can revise it. Your teacher in the class can teach you once, but here this video is with you. You can see it many a times and n number of times. So that will make all the concepts clear. As well as one more thing I'd like to tell you, students over here. Some of the students have mailed me to have this topics in Hindi also. So coming up in a few days with Hindi versions also. So if any question is there, if there any problem in understanding the language, then you can see those videos in Hindi also, and you can be sure to get 100% marks. As here I have said, you complete 100% of the course with 100% accuracy, then obviously you will be getting 100% marks. So thanks a lot for being with this video and listening to me, and take care of yourself, have a proper revision, and bye.